Hi, welcome back. Let us continue our discussion by having this example. So say we have 4 tangent squared z dz. Okay, so we have problem like this, and as you can see here, we don't have a direct formula that can be applied directly to evaluate this or to integrate this integrand for tangent square z dz. So we have here tangent u secant u tangent u, but it is very far from tangent square z dz. So as well as here we have secant square u du or cosecant u du, but we don't have something similar with tangent square. So in this case, we must think of something that we can apply in order for this integrand to modify into in order for us to produce some integrand that is similar to these trigonometric functions or in this kind of form, so that we can use these trigonometric functions here. Okay, so from your trigonometry, what can you say about this tangent square? Okay, from tangent square, recall your trigonometry, the identity. Okay, so say you already know that the identity containing this tangent square here, tangent square can be written, or it is also equal to secant square z minus 1. Okay, so based from your trigonometry, tangent square plus 1 is equal to secant square z. So by doing the algebra, we have tangent square z is equal to secant square z minus 1. Okay, so you need to again recall your algebra, recall your trigonometry, recall your calculus 1 and other mathematics. Okay, so from here we can now substitute this value to our tangent square z. So we have the integral of, let's move this constant outside, so tangent square z is just equal to secant square z minus 1 dz. Then from here you can now directly see that we already have the secant square u du here, so this is already in same form, so that we can now integrate it directly. And also we have a negative 1 here, which is constant, and we can use the basic rule in integration of constant. Okay, so finally we have 4 times the integral of secant square z dz minus the integral of d of z. Okay, and from that you can now integrate this 2 functions here. So integral of secant square z dz is tangent u minus the integral of dz is just equal to z. I mean, why did I use this? So this is wrong. So okay, tangent z dz plus c. So finally we have 4 tangent z minus z plus c as our final answer. This is now our final answer. Okay, so once again, let us review. We have 4 tangent square ZTZ, so we need to integrate this, or we need to evaluate this integrand. So we say that we don't have a direct integration formula regarding this tangent square here. So as we analyze, we transform this tangent square as its using its identity. So we say that the identity of this tangent square here is just secant square minus 1. Wherein when we simplify our integrand, then we come up with this form. Okay, and then while analyzing this form, we can directly say that we have the integrand of both secant square z and negative 1 here. So we can now simply integrate these two here. But this whole integrand here is or must be multiplied into 4. So we have here the bracket, and we can now simply integrate each term. So we integrate the secant square z dc, which is equal to tangent z, and the negative 1 dc is just only equal to z. Then multiply by this 4 constant 4 here, and then plus z. So finally our answer is 4 tangent z minus z plus c. Okay, so that's all for this video. I hope once again that you learned something from this, and see you on our next video.